1's trig answers were 1, negative root 2 over 2, root 3 over 3, negative 1, negative 2 over root 3, 0, negative root 2 over 2, and 8 was 1/2. Remember, in the second row, number 9 is negative 1, number 10 is negative 1, number 11 is negative 2 over root 3, number 12 is negative root 3, and then the arc, or inverse trig functions. Arc sine needs to be negative pi over 2 to pi over 2. So for number 13, your answer should have been negative pi over 3. One answer only. Number 14 is 2 pi over 3. 15, negative pi over 3. And 16 pi over 4. How'd you do there? Good, good. Glad to hear it. Okay. Just a quick note, I'll mention some of these I'll just give you the answers to, but some of these I just want to speak a little bit to. I had at least a few people say, I don't remember the order in which you do all this shit stuff. Please don't use memorization as a way to graph any parabola ever. Use conceptual knowledge. I would never think, well, do I shift it right or left or up or down? I don't. That'll fail you, especially with rotated conics, which you will do in college. Instead, think of it like this. The minimum of a parabola, whether it be sideways or vertical, is when the square is, what's the least a square can be? 0, okay? The vertex doesn't happen because mathematicians decide this is the way I'm going to make it. It's pretty. The vertex happens because that's where the 0 happens to the square. Where does the 0 happen to the square? When y is 2. When y is 2, what is the x that goes with that? 1. That's the vertex because that's where the square is 0. The vertex is at 1, 2, and afterwards you open a sideways parabola to the right because x equals y squared. It's always open to the right. The second one, obviously, is not a square root graph. It's more of a semicircle graph. It's the top half of a circle with radius 3, centered at the origin. What's the name for that kind of function? What's the vocabulary? If you see a fractional function, what is the typical name for that? That is a? Starts with an R. Rational function. Yes, rational function. Okay. That has, how many asymptotes does that have? 2. You answered too quickly. You didn't think. It's not 2, it's 3. Because you're only looking at the vertical. It also has a horizontal asymptote. It has 3. Would you be surprised to say that on an AP test? That's one of the most missed questions because people focus strictly on the vertical and they say there are 2 asymptotes there. There are 3. 3. Okay? So you have vertical asymptotes at negative 3 and 3, and x-intercept at 0, and then you can see the sign behavior. Last but not least, absolute value. We're going to do derivatives of absolute value functions, I think, Friday. So you need to know how to graph an absolute value. We'll write it as a piecewise in that lesson. But for now, you should have a downward opening parabola, but it doesn't actually end up being negative y's. The parts that are negative y's get flipped up. So you should have flex points that are flipping up at negative 2 and 2. Check. And then this one, I hope you said, well, I never do a sign test on a sum if I can help it. I need to make it one big product or quotient. So your first goal should have been to put that together into one big product or quotient, factor out in e to the x. Now, after that, if you get to this stage with you factor out e to the x, inside I have 2 square of x squared minus 1 squared. E to the x is always squared. That guy is always positive. Sorry. That's always positive. That's always positive. So the only true places where it can change sign are negative 1 and 1. My sign test yielded positive on the outsides. Now a bit of vocabulary. Non-negative. What does it mean? Okay, so there are actually 2 definitions. The English definition to non-negative is not negative. Okay, the math definition of non-negative is positive or 0. At negative 1, is it 0? It is not 0. It is undefined. And so the question is, shall you include negative 1 and 1? And the answer is No, you do not. It is strictly -1 to, or -infinity to -1, not inclusive, because although, yes, it's not negative, the math definition of non-negative is it is 0 or positive, and it's not 0 or positive. It doesn't exist. All right, cool. I think that's the end of that side. This, I don't know if you thought Rickman's an idiot to this question, but I surely did after doing this problem. Once again. So the roots are fine. The roots are not an issue. There are 3 roots. I imagine if you check the first one, you're probably fine. Do you really need to report the x and the y when they ask roots? No. When they ask roots, what's the implied y? 0. So you don't really need to say, hey, why is 0? You didn't need to show coordinates here, although it's not wrong if you did. You really just need to report the x's at which the roots occur. The dumb question, the intersection points are fine. I had 3 intersection points. Let's just check your x's. 0.147, 0.758, and 1.36. 306 or 307 if you like. Are those pretty good? Okay, this question is the stupid one. The relative extrema of f. Now, this, I would not blame you guys for not seeing this problem. Terrible. What is going on? This is making it worse. An old guy like me who grew up without a graphing calculator and graphed a ton of this stuff should have known better. What is x cubed by itself would look like this, yeah? Are you with me? Are you with me? Okay. Now, sinusoidal behavior would be something like this. It's negative sinusoidal. And the 4 helps it a little. Something like that, yeah? Now, old school graphing, you would then say, all right, what happens when I put these 2 guys together? For small x's, sine has a pretty big effect. So it's going to cause, when you put these 2 together, around the origin, it's going to cause some major dipsy-doing. But when you talk about way up here, when you talk really huge x's, adding a little sine wave onto that's not going to have a little bit of a huge effect. Out here, it's going to just have less and less and less of an effect. But mostly it's the cube that dominates. That said, though, it's still sinusoidal, so it's actually going to have more than I thought there were 4 extrema, because that's the window I chose. But there are actually tons of extrema, more than 4, at least 6 that I could find. So this was kind of a dumb question. I apologize. The sine causes it to wave quite a bit until the cube gets so big that it dominates. So there should actually be more than 4 extrema. Like I said, I found 6 at least, but that was a dumb question. Let's just blow it up. The only 2 that I felt were true were D and F on that asymptotic graph. Remember the definition of continuity. There are actually 2 ways to look at continuity. One is to say, does the limit from the right equal the limit from the left equal the point? In other words, a 3-part idea. Approach from the left, approach from the right, and the point itself have to all be the same. Some books actually just teach this as, well, if the limit from the left and the right are the same, then that's just the limit. And some people just say, does the limit equal the point? Either way, it's fine, but you have to investigate how to fill the hole. There's a hole there, in the hole has a y value of 1. Okay? We good there? Excuse me. For 7, the left hand, right hand, and the limit itself are all 1. D just gets to, do you know how to evaluate a piecewise, which branch to evaluate? If you have 2 answers to D, if you said, well, I'll put 3 into the top and it's 9, and 3 into the bottom it's 5, you don't understand this idea. You need to panic, okay? It's, if x is approaching 3, I must be in this region. I use that function only. It's only 5, not 9 and 5. Okay? And then E then is more of a proof to show it's continuous. I showed what the function approaches from the left, the right, and the point itself are all the same. And that's what allows you to claim continuity. It is continuous at 1. Questions on this? Up to here. I'm going a little fast, but I also want you to have plenty of time to work on your homework. Feel good? Please do stop me and say, whoa, whoa, slow down, buddy boy, if that's necessary. Okay. On number 8, average rate of change was 4/3. In terms of free response practice, you really need to get in the habit of showing where your answer comes from. On a free response, if you didn't show that piece, you would be losing points. So it's just good math. F is even, which implies that the y should be the same for any symmetric x. So f at -2 should be the same as f at +2, which is 3. Odd would imply changing the sign of y gives you an opposite, or changing the sign of x gives you an opposite y. So g of -1 would be the same as the opposite of what g is at +1, which is also 3, coincidentally. I didn't intend for that to happen. In fact, there are 3's all over the place. The inverse idea. This also we will do this semester. Derivatives of inverses. We haven't done that yet, except for inverse trig. Derivatives of inverses we'll cover this semester. You should have had 3. In essence, you're looking in the y column and saying not is where is x for, but where is y for, and what's the x that goes with that. 11. This is also something we'll tap into more this semester. I don't know if we talked about it at all last semester, but a condition differentiable means the derivative exists. And the derivative only exists if the function itself is continuous at a point. So when they say the function is differentiable, it's implied within that it's also continuous. It must be continuous. So then the IVT does apply. Because f is differentiable, f must be continuous. And by IVT, then as it passes from 4 to 6, it must pass through 5 along the way between x of 3 and x of 4. So say that well. Most of you can say that pretty well, so I'm not sweating it. I totally overthought 12. Why can't f be linear? Like a total clown, I looked at f and said, well, here the rate of change is 1, and here the rate of change is 1, but here the rate of change is 2, so that's why it can't be linear. Where's a better place to show f can't be linear? F prime, yeah. F prime, if f is linear, then f prime should always be the same, constant, right? I mean, if you have a linear function, then the derivative should always be m, or the slope, always the same. And you can see that f prime is not always the same at all values, and so it cannot be linear. Cool? This one, I expected it to be difficult. First of all, did you understand what the question was even asked? We got to get over it. We need to talk a little more here, people. This is class just full of smart people. You got to speak up. Talk to me. Do you understand what the question asks?
I think so.
Okay, what does it mean? Well, what did you think it means? And let's start there.
Does it have a max?
What kind of max?
Absolute.
That's absolutely the right. That's the right idea. Okay, it's symbol heavy, but within all that symbol stuff is the extreme value theorem. Does it have an absolute maximum? This is the thought process. Is there, now that C is an x value. Is there an x value within 1 to 4 such that f at that x value is greater than all other f or y values? Is there a y value greater than or equal to all other y values in the interval? Does f have to have some y value that's greater than or equal to all other y values? Now that goes to a bit of the extreme value theorem. Imagine a couple cases here. Look at this. Does it have an absolute max? Does it have an absolute max? No, it does not. Okay. So the fact that it goes forever doesn't necessarily keep it from having an absolute max. For example, this goes forever also, and does it have an absolute max? Yeah, okay. So if it goes forever, that might cause it not to have an absolute max. What about this? does that have an absolute max? Okay, now it's tempting to say, yeah, the point just below that empty dot. But what does that mean, just below that empty dot? So does this have an absolute max? And the answer is, it does not. Okay, there is no absolute. You can't name the highest y value. It's just, I know it's right below that, but it isn't. What does it equal? And then how about this? So the first point I want to make is that endpoints help. If you stopped it here and here, then does it have an absolute max and include them? With me? Okay. So closed interval. Endpoints or closed interval helps. But what if I said, all right, it has a closed interval at these points, but in between it went like this? Does that have an absolute max? Obviously no, okay? So continuity also is important. It's the combination of these two things. If you try and draw any function that's both continuous and has closed interval endpoints, it has to have an absolute max. No matter how you go from this point to this point, no matter what you do in between, it has to have a y that's greater than all other y's. Has to. That's the first part of the extreme value theorem. So that is very much the idea. F is continuous. Again, because it's differentiable, it's continuous. And on a closed interval, they included 1 to 4. So yeah, it has to have an absolute max. That's the extreme value theorem. There really are 3 existence formulas in Calculus 1 that you will start to know. The IVT, the MVT, and the EVT. Okay, there's 2 components to this. Did you get the right answer, and does your work stink? The right answer is 31/9 plus C, or some mathematical equivalent. And when I say show work properties of limits, the idea is that to see what this big thing equals, you just need to isolate the limits. So say I could figure out just what 2 times the limit of f is, divide by what g approaches, all squared, that should be there. Figure out what that approaches, figure out what c approaches, and then aggregate. That's really the properties of limits that are being shown. Some professors are super picky about that. If you don't show that work, they wouldn't give you much credit at all. Okay, so that's what I would call good work. Are you with me? Yes.
Why do you need to show the limit for 3 parentheses x plus 1 if there was no limit there to begin with?
Okay, that's my problem. So what my intention was I guess in my mind, I knew what I meant, and so in my mind it was the limit was applicable to all. So you read that as just the limit of this and that stuff. Yeah, that's my fault. You probably had something like 4/9 plus 3 x plus 1 plus c. That would be correct. But it was what I wrote. I should have put it in brackets. That's my fault. Sorry. If you felt the same, then you would be right. Okay, number 14 is a rational function, and we're trying to figure out based on the end behavior, in essence, based on what power of a, what would happen. The gotcha in here is the negative in the denominator. This is what caused most mistakes, not the concept itself, but the detail of the negative. For a greater power of, or a lesser power of x, it wouldn't really matter because you're going to get small divided by bigger, so it's going to approach 0. It would approach 0 from the negative side, actually, but it's still going to approach 0. If a equals 3, then it starts to be the case that these are almost identical, so 20 times huge over -4 times the same huge will approach -5. Not 5, -5. Okay? And then if a is greater than 3, then it's going to be 20 times a huge positive divided by -4 times a pretty huge positive. It'll get huger on top quicker, but it still will be negative. The negative in the denominator does contribute to the overall sign. Okay? in this semester, we'll divide that out and actually find the equation of the slant asymptote that would happen as a result once you do 3. Last but not least, if the function has a horizontal asymptote not at the x-axis, then that implies that there is some y value that the graph is approaching. That only happens if the powers are equal, and so that would imply that A must be equal. Cool? Okay, and behavior on that one, the dominant terms are 3x squared and negative x squared, so that's negative 3. That one's direct substitute. Remember, your first objective is to always direct substitute, so that would approach 1/14. Unless there's a continuity issue, you can assume that the point itself will match the limit. All right. Go through this. You learned a ton of identities last year. These are the main ones that you really have to know for AP calculus and for this semester. You should know the 3 Pythagorean identities. Sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. Do you know those by heart? Yes? Okay. Will you remember them in 20 years when you have a kid? Yes, you will. Okay. Sine of 2x is 2 sine of x, cosine of x. That's an important one. And cosine of 2x actually is one of the most important ones for this semester. Cosine of 2x could be any one of 3 different forms. Cosine squared minus sine squared. Somebody in the last class said plus sine squared. Why doesn't it make sense that it's plus sine squared? Because that would be 1. That would mean cosine of any 2 times any angle is 1. That's ridiculous. That's not logical. Okay? 2 cosine squared minus 1 and 1 minus 2 sine squared. Quick preview of coming attractions. Why would that be important? Well, imagine if you were integrating sine squared. It's really difficult to do, yeah? Because of the power. No matter how you try to use of it, there's no d to match it. There's a power issue. So you use what you no longer look at these as double angle identities. In calculus, you refer to these as power reduction identities. By replacing or saying cosine squared is equal to 1 minus 2 squared, you could actually reduce the power of this, which should be minus, and then integrate fine. So we'll use those a lot this year as power reduction identities. Need to know those. For A, again, hopefully show your setup. I had negative 8 over 3 pi squared. The limit of that, those approach 0, and 0 over 0. So 0 over 0 is actually a big part of this semester also. 0 over 0 could be 1, could be 0, could be a million things. That's called an indeterminate form, but you could use your calculator to find them. That implies then that for small zeros, sine of x is pretty much the same as x, which I believe you use in physics, if I'm not mistaken, or at least AP physics. Okay, for this, can you jot down this vertical asymptote, horizontal asymptote stuff to happen? There's 2 big ideas you need to have down in your brain. At a vertical asymptote, what's happening is x goes to a constant, y goes to plus or minus infinity. At a horizontal asymptote, it's the opposite. As x goes to plus or minus infinity, y goes to a constant. In both cases, you're talking about as one gets infinitely huge, the other variable approaches a constant. That's what asymptotic behavior boils down to. Okay, so if they ask, is the line x equals 0 vertical asymptote of f, it really means as x goes to 0, does y get infinitely large? And the answer is no. As x goes to 0, y goes to 1. We just looked at that. The limit as x goes to 0 is y gets closer and closer and closer to 1. If y gets closer and closer and closer to 1, that's not asymptotic behavior. There's a hole there. Okay? No vertical asymptote. The sandwich theorem, I can't remember if we talked about this thoroughly or we need to go over it a little. Do we need to go over this? Okay then. Here we go. Boom. There's two ideas at hand. The horizontal asymptote idea, then there's the limit idea / sandwich theorem. Okay? To prove there's a horizontal asymptote, I have to show that as x gets infinitely large, the function sine of x over x approaches 0. That would prove a horizontal asymptote. As x gets large, y goes to 0. So that horizontal asymptote really means prove the limit is 0. Okay? To prove the limit is 0, well, that's a little dicey. I can't do any canceling. The table is not really proof. That's where the sandwich theorem comes in. To actually find the limit is 0 mathematically, you use the sandwich theorem. Anytime you have sine or cosine, here's where the sandwich theorem comes in. You might start with saying, I know sine has to be between 1 and -1. Why is that? Why is sine between 1? Why can't sine be more than 1? Go back to the very definition of sine. What is the definition of sine? It's the ratio of, see, you use sine, the opposite to hypotenuse. So tell me, why can't that be more than 1? Yeah, because the opposite can't be more than the hypotenuse. You've gone so far past your tricks that you might not even remember that. Yeah, that's why it's tagged to 1. Okay, so great. I want to start saying, hey, well, what about this then? So I'm going to now start to build out to this, kind of like in an identity. Proofs are all kind of like identities. Let's start by getting the x in there. Can I divide by in an inequality? Remember, inequalities are delicate kind of things. There's certain rules with inequalities. If I divide by a number, are these inequalities cool? Or is there sometimes a problem? I'll remind you, if you divide by a positive, let's go here. True?
Yes.
Okay, if I divide by a positive, is truth maintained? Yes, 1 is still less than 3/2. But if I divide by a negative, oops, is truth maintained? Is -2 less than -3? No, it's no longer true. So when you divide by a negative, you must switch the inequality, okay? So there is danger here to saying, now I feel like dividing by x. You can only do so if you're mathematically justified in doing so. Otherwise, people will say, well, why didn't you switch the sign? So tell me, why do I know that I can do that and not worry about switching the sign? Because what I'm trying to prove is here, and I'm looking at what happens as x goes to positive infinity, okay? Because x goes to positive infinity, I don't have to sweat dividing by x. You follow? Now the second part is, all right, what about the limit? Now, this means the graph of this is less than the graph of this, which is the graph of less than the graph of that. That would mean that for any values, including in a table, if I wanted to look at what happens to the outcomes of this as x goes to infinity, they would all be the same as, or strictly less than the outcomes of that, or strictly less than the outcomes of that. Right? So we built out to that in 2 steps. The last step is to evaluate the edges. What is the limit as x goes to infinity of -1 over x? What does it go to? 0. Okay? In a negative probably way. The inside I don't know, that's the question. But what does 1 over x go to? As x goes to 0, 1 over a million, 1 over a billion, 1 over a trillion goes to 0. It's being squeezed. It's between -1 billionth and 1 billion, -1 trillionth and 1 trillion. It must be right in between, and therefore it must be 0. And therefore y equals 0 is a horizontal asymptote. Because the values of the outcome or the function approach 0, there must be a horizontal asymptote too. Okay, all that is extra stuff. That one's a little more abstract. Last but not least, if I factor this, I see that there's a common factor at -5, x minus 5, which means what graphically if there's a common factor talking about? There's a hole. Okay, so question is there a vertical asymptote at both 5 and -5? The answer is no. There's only a vertical asymptote at -5. There's a hole at x equals 5. Horizontal asymptotes are at F imply what's the end behavior, or what, to justify that you'll say what's the limit as x goes to plus or minus infinity, and whether x goes to positive or negative infinity, those start to knock each other out and y approaches 1. So there is a horizontal asymptote at y equal 1. And then finally, can a piecewise function make this continuous? And the answer is yes and no. At A, there was, so just so we're clear here, they say this is the rule for almost all. It's this curvy thing, okay? At x equal 5, y is A. And at x equal -5, y is b, wherever that needs to be. In order for it to be continuous at 5, I need to fill the hole. So for A, I need to say the limit as x goes to 5 needs to equal A. Well, the limit as x goes to 5 would be what happens as that hole is removed. And as x goes to 5, the other stuff approaches 3/10. So A must be 3/10 in order to fill the hole. As far as the vertical asymptote, I mean, you've got a vertical asymptote at -5. It doesn't matter where you put B. I could put B here, 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 and here. It doesn't matter where you put B. It is never going to be continuous. Never. There's a vertical asymptote there. So in terms of if it's possible, it's not possible. No B will make the function continuous because there's a vertical asymptote. Okay? Questions? Anything I said wrongly or went too fast? Okay, make sure I get that by the end of the day, and the rest of the period is for you to work on the derivative review. If you do have questions individually, let me know on the last day's homework or the next one. All right, are you going to take it to strangers in the night, two lonely people, we were strangers in the night. Up to the level 21, I'm supposed to have 21. Strangers in the night. Exchanging words and oops, I forgot to stop the